So let's take a look at our difference quotient. For the difference quotient, it's listed on here. We have f of x plus h minus f of x over h. And so for that difference quotient, we're going to plug in the pieces as you see. We're going to evaluate that f of x plus h so we can use it in the front. From there, we're going to subtract off the f of x. Then we're going to divide by h. So the thing that we have to do is calculate that f of x plus h so that we can get that difference quotient. And it's going to, what a difference quotient does is it gives us this, this rate, and we use it to get slope. The difference is that when we have those basic lines where we know how to pick out the slope, that's easy. It's just that number. But as you progress in your math courses, it's not just a plain number anymore. And so we can use that difference quotient to help get that. Okay. And so that's what we're going to do. We're going to figure out the f of x plus h, then substitute in the f of x and the f of x plus h into the formula. Let's take a look. So I need to find and simplify that difference quotient. Remember, the difference quotient is that f of x plus h minus f of x over h. If any of you have had calculus in the past, you may or may not have seen this f of x plus h depending on what all you went into. If you have to go on to take calculus, you definitely will see this difference quotient in a college calculus course. So in number 1, we have the function as 6x plus 1. First thing I need to do is find that f of x plus h. My f of x plus h isn't going to be terribly difficult to find or to determine. But I just need my stylus to work. There we go. There's my f of x, 6x plus 1. My f of x plus h, I have to figure that out. So wherever there was an x, I replace it with an x plus h in parentheses. And then I simplify, which is another way to say clean up. So I'm going to take the 6, and I'm going to distribute it into those parentheses and get 6x plus 6h plus 1 as my f of x plus h. Our part's done. Now I'm ready to use that formula. Here's the fun part that for some reason students do not like. So instead of writing f of x plus h, I'm going to write 6x plus 6h plus 1. Then I'm going to write my minus sign with a big old fat parentheses. And I'm writing a big old fat parentheses because inside that parentheses, I'm going to write the 6x plus 1. Yes, we will need to put parentheses around this little booger. And the reason why we need to put parentheses around that f of x is because we have to subtract the entire f of x. Then in my denominator, I write an h. So let's talk about subtracting that entire f of x. When we say we have to subtract the f of x, and you have to do the entire f of x, that means that when I get to that back half, I have to distribute this negative. So I'm going to write a minus 6x minus 1 all over h. Now I can combine my like terms to clean things up. 6x with a minus 6x, those are out the window. 1 with a minus 1, that's gone too. And I'm left with a 6h over h. See, that's the fun part that students do not like. Everything knocks out. I'm just left with the part with the h, that's 6h. And now I can clean that up. 6h over h is going to clean up to give you just a 6. Because I'll be able to cancel this h with that h. If you remember how to calculate slope of a line, that's what this is. This is a linear equation. That's at y equals mx plus b. This is my slope right here, 6. Let's look at number 2 quickly. Number 2 is a trick. Number 2 says f of x equals 7. We still need that difference quotient, so I need my f of x plus h. And the rule is you write a parentheses where you see an x. Well, I don't write a parentheses because I don't see an x. So that means I don't have an x plus h to fill in. So that's done. F of x plus h is 7, the same as f of x. Now when I go to plug things in, the f of x plus h is 7. The f of x is 7, so I have 7 minus 7 over h. That's giving me 0 over h. And when I take 0 and divide it by anything, automatically I'm getting a 0. That's number 2 is actually an equation for a horizontal line, and a horizontal line has a slope of 0. Now let's look at number 3. On number 3, we have a little more work to do. Our f of x on number 3 is x squared minus 5x plus 8. So the first thing I need is my f of x plus h. So where there's an x, I replace it with x plus h, whole thing squared. On that first one, on that second one, I get minus 5 times that x plus h plus 8. Now I need to take care of that x plus h whole thing squared. We can take it on side to kind of keep things nice and neat, or we can go ahead and take care of it in the problem. I'm going to go ahead and take care of it in the problem. Remember that x plus h whole thing squared means to write that x plus h down twice and multiply it out. When I write it down twice and multiply it out, I obtain x squared plus hx plus hx plus h squared. Remember, there's another video where we're evaluating the functions. And in that video, I also do an example with an x plus h that's being evaluated. So here I can combine the hx to get two hx's. And this is x times x for the x squared, x times h for the hx here, and h times x for this hx, and h times h for that last h squared. Okay. The two hx's get combined, and hx plus an hx gives you two hx's. So I have that part. Now I'm ready to use that difference quotient, f of x plus h minus f of x over h. So that f of x plus h part gives us x squared plus 2hx plus h squared. Oh, booger. Let's go back to that f of x plus h squared. I'm sorry, f of x plus h. I only calculated the x plus h whole thing squared. I didn't finish it out. Let's go back. So that f of x plus h, I did this part, x plus h whole thing squared. I need the rest. So I need to take that negative 5 and distribute it to get a negative 5x minus 5h, and then copy down that plus 8. From there, I can combine any like terms if I have any, and I don't. So when I come over to do that difference quotient, I have the x squared plus 2hx plus h squared. I don't have enough room here. I'm going to scoot it up a little. Minus 5x, come on stylus, minus 5h plus 8. That's the f of x plus h. Now I have to subtract all the f of x. Once my stylus decides it's going to stop erasing what I'm writing. There we go. So I need to subtract off the f of x. Remember, I'm going to put it in parentheses. F of x was x squared minus 5x plus 8. All that gets written over h. So now I'm going to go ahead, copy down that f of x plus h part. And then I'm going to distribute that negative. So I'm going to have a negative x squared plus 5x minus 8. Because remember, I have to distribute the negative. So this is a negative x squared. Negative times a negative is a positive 5x. And negative times a plus 8 gives me a negative 8. All of that is over h. And now I look for the excitement and the fun part. Knocking everybody out. I have an x squared I can knock out with a negative x squared. I have a negative 5x I can knock out with a positive 5x. I have a plus 8 I can knock out with a negative 8. And that leaves me with a 2hx plus h squared minus 5h. Everybody's left has an h. Now I have to do some fancy math stuff. I have to factor out an h. And I said I was factoring it out, and I'm writing it without factoring it out. There we go. The reason why I have to factor out an h is so that I can cancel the h in the denominator. Each piece in the numerator has an h in it, so I can pull an h out. And then once I do that, I cancel this h with that h. And what I'm left with is that 2x plus h minus 5. We did all that work and it's simplified to that 2x plus h minus 5. And that's our final answer, and that's our difference quotient for the most part. Quick comment, we can actually use a difference quotient to obtain something called a derivative. We can also use it to obtain the average rate of change, as a side note.